Hello again, and welcome back to Educator.com's Advanced PHP with MySQL course. In today's lesson, we're going to be continuing discussing the topic of classes versus objects. We're going to have a review of what classes and objects are and the differences between the two, because that's going to become important when we learn about what's known as static properties and static methods. It's so far what we've been working with, as you'll find out, have been known as instant properties and instance methods. They're properties of a class and methods of a class that relate to a specific instance of that class. We're going to learn about something a little different. It's on more of a class level. We're going to talk about an operator called the scope resolution operator, which is going to allow us to access these static properties and methods that we're going to learn about. And then we're also going to learn about constants in classes. We know about being able to define constants in our regular PHP files. We're going to learn about how to define them on a class level, at the class level. So basically, a class, as we know, is essentially a user-defined data type. And when you create an object, what you're doing is creating an instance of that class. You're basically instantiating almost like a copy of that class, and you're filling in the values for the properties of it. Essentially, what you have between a class and objects is a one-to-many relationship. You have one class definition, and you can have as many different object instances of that class as you need. The class sort of provides the template, and the objects are sort of the realization of that class. But in the case of each instance is essentially, as we had mentioned, is basically their own version of that class. So they have their own version of all of the properties. So for example, we've learned about object properties. Object properties defined in a class definition, they get initialized and set when you create or instantiate an object. Those properties are specific to that particular instance. So each instance of an object has its own copy of, for example, if a person object had the first name property, each object, person object you create would have its own copy of the first name property, and it'd be specific to that instance. And so for that reason, we haven't specifically called them that, but the distinction is going to become clear today, is those are known as instance properties. So all of the properties that we've been dealing with so far with our classes are known as instance properties. They're properties that are specific to each instance of a class, and basically each time you instantiate a class as an object, it gets its sort of own copy, own version of those properties. And they'll be referred to as instance properties. Static properties is sort of what we're going to talk about today. And static properties are kind of, in a way, they're like class properties. They're basically properties that are shared, whose values are shared between all of the instances of a particular class. So whereas you might have, in your class definition, you have a first name, or let's say in our person class we have a first name property. Well, that's an instance variable if we define it as we have been. And that means that it's a per instance property, meaning that basically each instance of that class has its own copy of that property. However, a static property is a per class, meaning that there's basically one property defined in that class definition that all of the different instances have access to, but it's not like they get their own individual copy. So basically, if one class updates this static property or one instance of a class updates a static property of the class, it affects all the other classes, and that they basically all read that same value. The way you declare a static property in a class definition is using the static keyword. So whereas before we'd sort of just been saying public num people, and that would be our property definition. Now we're adding the static keyword. We're saying public static num people, and we're giving it an initial value of 0. So basically what this statement says, we're declaring a public property that's a static property. It's going to be called num people, and its initial value is 0. And this would be contained within a class definition, just with all your other properties. One other thing to note about static properties is because they're not specific to an instance of the class, they're relate to the entire class, or basically all of the different instances of that class. You don't actually have to have an instantiated object in order to access them. Normally, for example, let's say we have a person class and it had a property first name, for example. Well, to access that first name property, we would write something like this. And what this is a reference to an instance, to this instance of the person object that was created. Well, and that's why it's called actually an instance variable, because this copy of first name is specific to this A variable right here. Well, because static properties aren't specific to a particular instance, you don't actually reference them using an object variable. And we're going to see about that in the next slide, about how you actually access them. So what PHP provides is the scope resolution operator, which is basically it's two colons, one right after the other, and that's how you access static properties. So for example, if we had a person class where we defined a static property called numPeople, just as in the last slide, numPeople equals 0, public static numPeople equals 0. Well, in order to access the value of that static variable outside of the class, the way you access it is you write the name of the class, followed by the scope resolution operator, followed by the name of the variable, including the $sign. And so outside of a class, this would be how you reference numPeople. And the reason you can access it, it's basically in a way like, it's essentially the same thing as, you could call it almost like a class property, because numPeople is a property of this person class, because there's only one version of it. There's not a version for each instance of the person class. And you can do that for public static properties. In addition, if you're trying to access a static property from within a class method, for example, you have a class method defined within the person class, and you want to access this static property, you do so using what's this keyword self. So if this was within, for example, a function or a method within a class definition, in order to access the numPeople static property of this class of this object, you would say self, and then you have two colons followed by the variable name, and again, you include the $sign, which is a little different because when we use access instance variables, and we use this arrow operator, and we were to access, if we had a property called numPeople, we'd access it like this, without the $sign. So that's one definite distinction between how accessing properties, static properties versus instance properties. And then another thing to note is that outside of a class, you can't access a static property using the arrow operator. So for example, if we had this numPeople static property defined in a person class, we would not be able to access it using this arrow syntax. We couldn't, assuming A was a instance of a person object, we couldn't use this arrow operator in order to be able to access this numPeople static property. The way you do it is you have to have the name of the class with the scope resolution operator. So let's actually take a look at sort of a basic example of static properties in action. We have this person class that we defined. It has two private instance properties, and these are first name and last name, and they're particular to every instance of the person class that gets instantiated. So every person object that's created gets their own copy of these. We have a constructor that basically takes two parameters. One is the first name and the last name that you're going to set for the person. Here we set these instance variables, or instance properties. And then we're just also outputting a message in the constructor just to say we're creating a person, first name and last name. Now up here, what we have is a static variable. You can see here with the keyword static, it's called public. We say public static. We're calling the static property for this person class description, and it's basically a description of the class. It says this class represents a person. So it kind of makes sense that for any person class that you have out there, if you wanted to get a description of it, they'd all might have the same description. This represents a person. So this may not be the most practical example, but it's used to demonstrate the use of a static property. I'll show a little more practical example in a couple of slides, or a couple of examples. So if we look at a script called staticproperties.php, we have an include statement that includes that person class that we just looked at. And then what we have, and actually let me bring this down to another line. What we have is just a message that says I'm outputting this static description variable, static description property of the person class. And the way we access that is by person, the name of the class, the scope resolution operator, which is two colons, followed by the name of the variable, the name of the static property, including the $sign. So when we echo, we're saying, but we're just basically saying the value of person : description equals, and then we're outputting it using this concatenation operation. If we load this script up and we take a look at static properties.php, we can see person : blow it up a little bit. Person : description equals, the value of it equals, this class represents a person. And if we go back and look at our person class, we can see that that is the value that we had assigned to this static property. So that's how, outside of a class, you access a static property. You use the class name, resolution operator, and then the name of the property. We'd also talked about being able to access it from within a class. So now we have the same class here, except we've added another instance, what we're going to call, and we're going to learn about in a minute, it's called an instance method. Up to this point, we've just been referring it to as an object method called getDescription, and all it does is it allows you to access, it basically just returns the value of this class's static property description. And as we mentioned in the slide, when we're trying to access a static property from within a class, a method, within an object method, you use it using the self keyword. When we were outside, we used the person keyword, the name of the class. And you actually can do that within the class, but typically what you do is you use the self keyword, because self means the class I'm referring to is the same class of this object instance, which would be a person class, and I want to get the description property. So what we have here is we go ahead and include our person, this new person class definition, create two new people, a Joe Smith and a Jane Jones, and then what we do is we call, or we're calling the getDescription instance method. It's an object method. We're going to learn about static methods in a little bit, but for now it's just a regular method like we've been using. And what that's going to do is as we saw, it's going to return the value of the static variable description. So here we're outputting the getDescription variable, the description static property for person 1 and person 2. What we'll see is whether they're the same property. And then what we're going to do is we're actually going to change the property. Using the syntax for accessing a static variable outside of a class, where you use the class name and the scope resolution operator, we're going to set the static variable description for person equal to this new description, no description available. Then what we're going to do is we're going to call this getDescription method on each of these person objects, and what we're going to see is that it's updated for both of them. And that kind of, so in this example, we sort of learn about how to access a static property from within a class method or an object method, and then we also sort of demonstrates how that one static property is for all of the different instances of a class. When we call getDescription on this person 1 and person 2 object, and it returns that static variable, they're both going to have that same value that they return it to. You can't have a separate, for example, you can't have a separate description, a separate value for the static property description for each instance of a class. It's the same for all the classes of that type. So if we go and look at the script in a browser, inside class.php, we can see creating two person instances, and there's some output from our constructor. We've created a person, Joe Smith and Jane Jones. And then we can see that when we first try to output the class property, or the static property, which is before we changed it, it was immediately after we created these person objects. So for example, we instantiate the person objects, and then we immediately output the static variable description, and the static default, the value for that variable, this class represents person. We can see that it outputs this class represents a person. Now when we go back and look at inside class after we've changed it to no description available, when we go back and run that same getDescription method that is going to return the value of the static variable description, both objects are going to return that same description, or that same string, no description available. And we can see the second time we call it, they both output no description available. So somewhat of a more useful example of using an instance property is maybe is something, an instance counter, sometimes called a reference counter, is keeping track of the number of instances that you have of a particular class. For example, each time you create a person object, if you have a person constructor, that constructor is going to get called. What you can do is increment this. For example, here we have a static variable for the person class called numPeople. And this variable is the same for all instances of the person class. So every time in our constructor, what we do is we increment it by 1. So basically, every time we create a new person object, we're incrementing this static variable numPeople equals 1. So anytime outside the class, we reference this static variable person : numPeople, and we see what its value is. It's going to equal the number of times we've run this constructor, and it's going to be the same across all different classes. So when we increment numPeople here, it doesn't just do it for this instance, any particular instance of this class. It does it for all of the person classes. So we've just changed our constructor a little bit to basically increment this sort of counter variable called numPeople. And then the other thing that we can do is that when we can create a destructor that when the destructor is run, when the object is destroyed, it decrements the numPeople static variable. So every time we create a person object, the counter is going to go up by 1. Every time we get rid of it, the counter is going to go down by 1. So we have a script here where we define 3 different people, or we define create 3 different instances of a person object that all have their own first name and last name instance properties, but they all share the same numPeople static property. And then we have a statement here that just outputs, after we've created all these, it outputs a statement that says the current number of person instances is, and then we access that static variable person numPeople. In this case, it's going to say 3 because we've created 3 objects, 3 person objects. The constructor's called 3 times. It's been incremented, and for that case, it's been incremented 3 times. Then what we're going to do is we're going to get rid of one of the person objects. We're going to set it equal to null. That's going to implicitly call the destructor, which is going to decrement it by 1. So now it's going to say the current number of person instances equals 2 when we again try to reference person numPeople. So if we go and look at this script in the browser, we can see sort of an outline of what happens. When actually we called before we even created any of the objects, I had an output statement that said that output that static variable for person numPeople. So actually, even for a class, you can even if you haven't even instantiated an object of the class person, you can still access its static properties because they're basically specific to the class, not to a particular instance. So actually, if we go back and look at the code, I missed mentioning this line here, where actually before we've even created any person objects, we're still able to access this numPeople static property of the person class because it's basically on a class level rather than an instance level. And if we can see, we'd initialize it to 0. So when we first run this output, it's going to say the current number of person instances is 0. Then we say we're creating 3 person instances, and it shows us the 3 people we created. When we output now the value of that static property, numPeople, it's going to say 3. We destroy a person instance. We get rid of the first one, Joe Smith. And then when we output the static value again, numPeople, we can say the current number of instances is 2. And so it shows that it was able to decrement. And down here you can see these destroying messages come from our destructor. And the reason they're down here is because, as we know, when a script ends, the PHP destroys all of the objects, or calls a destructor on any objects that were still being used. And so since these objects were in use, their destructors get called automatically. So even though we didn't specifically call them, that's why they show up here at the bottom. And so that's somewhat of a more practical example of how you might use a static variable to keep track of, for example, the number of instances of a particular class. And the reason you can do that is because it's the same for all of the different instances, and when each one updates that static variable, all the other ones know about it. So now we're going to talk about something called static methods, which I kind of hinted at a little bit. And it's essentially sort of the analog of where static properties are to instance properties, static methods are to instance methods. And instance methods we haven't talked about, but basically what we've been declaring so far and defining in our class definitions have been instance methods. They are methods that you call using an instance of an object. For example, if we have an object A and we wanted to say get name, this is an example of an instance method. It works on an instance of a particular object. It's going to have access to the instance properties of this particular instance, whatever class it may be, and you actually use the arrow operator to get access to it because it's specific to an instance of a class. A static method, on the other hand, is not specific to an instance of a class. And we're actually going to see that you actually access it using the scope resolution operator as well. The way you declare a static method is just like you do any other method in a class, except you include the static keyword. And because static methods are not associated with a particular instance of a class, they can't access this variable within their definitions. Now, if you remember, this should make sense because if you remember that this variable, when we use it within a class, an object, what we're now going to refer to as instant methods, this refers to this particular instance of an object. Because a static method doesn't relate to an instance, it doesn't know about this. It doesn't know about any particular object. It just knows about the class definition as a whole. So you can't actually access this within static methods, or you'll get an error. And as mentioned, the non-static methods that we have been, which is what we've been using up to now, are called instant methods. And static methods are called using the scope resolution operator, just as we did with the static properties. We're going to see that in a second. Outside of the class, you preface it with the class name. So, for example, if first name, get name, for example, was a static public method, we would call it like this from outside the class. Within the class, we would call it within a class method, we would call it using the self keyword. And again, note that we're using this scope resolution operator as opposed to the arrow operator because we're not accessing a particular instance of a class. So let's take a look at, created this class called integer that basically is sort of an object that wraps an integer value. It has one private instance property that's it's called int val, and basically it just represents an integer. So when we call our constructor, we pass it an integer, 1, 2, 3, whatever, and then our constructor sets int val equal to that integer. We have a object method or an instance method called add, in which we can pass it an integer as a parameter, and what it's going to do is it's going to access whatever particular instance we're calling it on, this instance. It's going to access its current value, its current int value, add it to whatever you passed in, and then return it. So if we look at our code, here we're creating a integer variable, or an integer instance, just as we do normally, using the new operator. We're passing it the integer that we want to set that class to equal to, in this case 1, and then we're just saying we're adding 1 to it, and we're saying the sum of 1 and an integer with the value 1 equals, and then we're calling the add method, the add instance method, and passing it 1. So we're saying add 1 to our current integer, which is already 1, so it's going to output 2. Here you can see, because this is an instance method, it uses this arrow or dash greater than operator to access that instance method, and it does so on a variable that has been set to a new instance, or to an instance of the integer class. Now on the other hand, we could define a static method in this class with the static keyword called add integers, where we simply pass it 2 integers, and it just returns the addition of them. So it does the function for us, but we don't actually need to access any object properties. We don't need to access any instance properties. Whereas up here, because this was an object method and we wanted to add something, we accessed what the current integer value of this integer object was, and then add it to the value that was passed in. Now this is sort of it's basically like a standalone function, but within the context of a class. So now, if we want to add 1 plus 1, instead we could access that static method, add integers, pass it the parameters 1 and 1, and the way we call it is by prefacing it with the name of the class and the scope resolution operator. So this is saying call the add integers static method defined in the integer class and pass it the parameters 1 and 1, and it's going to return the addition of those. So when we view our script, we're going to see the sum of 1 and our integer object that has an int value equals 2. Integer value equal to 1 is going to equal 2, and then when we call the static method, the sum of 1 and 1 equals 2. So in this case, we haven't acted on an instance. And one thing to note is that I mentioned that just like with static properties, you can access static methods within a class as well, within an object as well. And so in this case, we actually could do this. If we wanted to, we could call this add integers method from within our add function and have that do all the work. It doesn't really make sense, but this is just an example to show how you would access a static method within another class method. Use the self keyword followed by the scope resolution operator, then the name of the method, and then in this case we would pass it two values because it's a function that takes two integers. In this case we're going to pass it the integer value of this particular instance of the object, and then we're going to pass it to add to it the integer that we pass in to this add method. Now when we go ahead and run our script, we're going to see that the same thing as output, because if we look back here, when we call int add1, what we're doing is we're saying call the add instance method on this instance of the integer. It's going to go to our integer class. It's going to call this add method, which then calls this static method add integers, and it gives it the value. It says add the current value of this integer object plus the value that we've passed in. And when we refresh our script, it's going to show the same thing. So that's a way to also access a static method within another object method. So just to kind of try some things up in maybe a more visual fashion, we have sort of this class object diagram that we kind of looked at a little bit in when we first introduced objects. So let's say we have this person. This is a class that we've defined in some class definition file somewhere, and this is sort of shorthand. This isn't correct syntax, but let's say we've defined three properties for this person class. First name and last name are both instance properties, so they're particular to each instance of a class. And then we're defining a static property called DESC, which is short for description. And so that's going to be a property that is the same for all of the different instances of a person class. Then we're going to define two methods. We're going to define an instance method called getFullName, which is going to operate on a particular instance of a class, and it's going to have access to the instance properties of a particular class. We're also going to define a static method called getDESC, which is just going to return the value of this static variable description. And so this is a static method. So basically, when we create, for example, if we use the new keyword person, every time we did that, we'd be creating an instance of the person class. So this is an instance of the person class. In this case, maybe we assign it to the variable called person1. So now we have an object, and an object is an instance of this class. And an object gets its own copies of instance properties. So we're going to assign Joe, for example, to the first name property, instance property, Smith to the last name instance property. In addition, it gets its own copy in a way of getFullName. So when you call getFullName on this instance, maybe you would call it like this, ... and maybe it would return the concatenation of first name and last name. This method is an instance method that has access to these instance variables. So essentially what I've shown is that in here we've just created two objects, person1 and person2. You can see that the names that are the properties that are instance properties and the instance methods, they sort of get their own copy made in each object that's created, each instance of an object. Now however, this static method sort of stays up here, and so when you access a static method or a static property, it's almost like you're calling them on the class itself. Whereas down here you would call it you would access the instance properties or instance methods using the arrow operator. Now we have this new scope resolution operator to access static properties, for this case, description. And that's how we would access that. So it's basically kind of like all of the things that are static stay in the class. It's almost like a class in a way is an object of its own self. It has its own properties and it has its own methods. In this case, it has its own sort of description method that's specific just to that person class. It has its own getDescription method which is specific to that person class that anybody can call, assuming they're public methods, but it doesn't have access to these instance methods, to these instance properties and these instance methods. Those are particular to each new object that's created. So basically, again, it's just and this kind of, because this is kind of a tricky concept, which is why I'm kind of focusing on it a lot, is just that when you create an instance of a class, any non-static properties or non-static methods, which are instance properties and instance methods, basically get their own copy created for that particular instance. The static properties and the static methods don't sort of get copied. They have basically one copy that sort of resides in this global class definition that all of the objects have access to, and it's shared between all the objects, between all the instances of the objects. So one other related topic is class constants. We know how to define constants within our regular scripts. Well, you can define a constant within a class that's specific to that class. You do it with the const keyword, and then you define the constant as you normally would. Here, the nomenclature, it's just alphanumeric characters. The same rules for naming a variable, except there's no dollar sign, and the convention is still to capitalize all the letters of a constant's name. And then you provide it a value. So here we're declaring a math class, and we're declaring a constant in this math class called pi, setting it equal to approximate value pi 3.14. The way you access a class constant, because it's constant, it can't change, so it's going to be the same in all the different classes. So it makes sense that you would access it kind of like a static property, and you do that outside the class using the the scope resolution operator again. So you have the class name, in this case math, the scope resolution operator, followed by the name of the constant. And that's how you would access that from outside the class. Inside the class, you would use the self keyword. And then, again, notice the one thing here is that there's no dollar sign. If pi were a static property, you would access it maybe like that after the scope resolution operator. So that's one key thing to note between accessing static class properties and static class constants is the absence of the dollar sign. So let's take a look at an example of that. Created a class called circle. We defined a constant in it, pi. Pi equals 3.14. And then we define a static function, which is a function that is just particular to circle class. Anybody that can use the circle class that knows about the circle class can access this public static function. And basically what it does is it calculates the area of a circle. You pass it the radius, and the formula for the area of a circle is pi r squared, pi times the radius times the radius. So basically what this function does is it accesses this class constant pi using the self keyword and the scope resolution operator, and then it says multiply it times the radius twice. So you can call this function in a standalone way, and you call it the same way that we learned about accessing static methods, and you would call it by using the name of the class circle, the scope resolution operator, the name of the static method that we want to call, and then also the parameter that we're passing. We're saying we want the area of a circle with radius 2. So this is an example of calling this area static method on a circle class that makes use of this constant pi. And then up here we just have an output statement that shows how we access the variable, the class constant pi outside of the class, and we use circle, the class name, the scope resolution operator, and then the name of the constant. And that again is different from when we access it within a class function, class method, because here we use the self keyword. So if we were to go ahead and load this, we can see that it outputs the value of pi is 3.14, so we were able to access that class constant using the scope resolution operator and the class name circle. And then we were also to calculate the area of a circle with radius 2 by accessing that static method called area using the circle class name, the scope resolution operator, and area. So for the homework challenge, what I'd like you to do is build upon this circle class that we just talked about from lecture example version 5. And basically what I'd like you to do is add an instance property to this class called radius. It's going to represent the radius of a circle. And that is static property, a public static property called numCircles. And we're going to use that as a instance counter. So what we're going to have you do is create a constructor that takes a radius as its parameter, and what it's going to do is going to set that radius instance property that you'll be declaring equal to whatever you pass in, whatever value you pass in, and then it's also in the constructor it's going to increment the static property numCircles by 1. So that's going to sort of keep that reference count, because that NumCircles is going to be for all of the circle classes. I also want you to create a destructor that when it's called, it decrements NumCircles by 1. And so that's going to basically, every time an object is created, that static variable NumCircles is going to be increased by 1. Every time an object is destructed, it's going to be decreased by 1. Then just output the value of the constant pi, which is already defined in the class that we saw, and that'll just be practice accessing a class constant using the scope resolution operator. Use the static area method, just like we had in our example, to output a circle, the radius of a circle with a radius of 2. And then I want you to create an instance of the circle class. Assign it, pass the constructor a value 2. So what it's going to do is it should take, the circle constructor should take the value 2, set its instance property radius, set it equal to 2, and then create a calc area instance method, which is going to calculate the area of a particular instance of a circle object. So this is going to be an instance method, not a static method. It's going to have access to this variable, so you'll be able to access the radius using this, followed by the arrow, followed by radius. So use that, and that way, and within your calc area method, you'll be able to grab the value of the radius property of that particular instance, calculate the area, and return it. And when you call it, let's say you defined a circle variable and you call it circle1, you would be calling this method using the arrow operator. And note that we don't have to pass it the value of 2 because the circle object already has a radius property defined, that it already knows about it. And that's how you access it with this. Repeat step 6 and 7 for another circle. So basically create 2 circle objects. Then output the value of the static property NumCircles after you've created these 2, and you should verify that the value is 2. That shows that you're properly incrementing that static variable that's keeping track of our instances. Then destroy one of the circle objects by, you just set it equal to null, and then when you re-output the NumCircles property and verify that it's been decremented to the value of 1. And so that'll give you practice with accessing a static variable outside of a class. So you'd be accessing it circle, what was it called? NumCircles. So this homework example will give you practice accessing class constants, class static variables or properties, and class static methods. So that ends today's lesson. Thank you for watching Educator.com. I look forward to seeing you next time.